The James Webb Space Telescope, JWST, has now produced another image that shows something is seriously wrong with our universe. Either our space is going crazy, which would mean that it has some kind of intelligence, or our scientists simply got it wrong. The fact is that since the launch of the new telescope, we are experiencing a crisis in world science the likes of which we have never seen before. It seems as if the new findings are trying to tell us something urgent, but so far, scientists are arguing more than they can present us with real new facts and truths. Does this mean the end of everything? No stone has been left unturned since the JWST showed us images of galaxies that are so old and so perfect that they shouldn't even exist. This was the beginning of a drama in modern science that continues to the present day. More and more images show even crazier phenomena and impossibilities. Nothing in the young universe is the way scientists thought it would be. And now it's also clear that the entire universe is not the way our scientists thought it would be. Until now, researchers have assumed that the universe is homogeneous, meaning that its large structures are largely uniform in shape. But now, there are dozens of indications that the universe is, in fact, inhomogeneous, and this calls into question some of the basic assumptions about the nature of the cosmos. The idea of a homogeneous universe goes back to the cosmology of the early 20th century. Albert Einstein introduced the cosmological constant in his general theory of relativity, describing a static universe that neither expands nor contracts. Little later, it became clear that we do not live in a static universe, but that this space with all its phenomena is highly dynamic. There is nothing that does not move in this universe. However, the physicist Alexander Friedmann came to the conclusion that Einstein's field equations also work with an expanding or contracting universe. Georges Lemaitre then proposed the idea of the Big Bang, in which the universe expanded from a single point. These developments led to the idea of a homogeneous and isotropic universe, which is anchored in the so-called cosmological principle. The principle states that the universe is homogeneous and isotropic on large scales, meaning that it looks the same everywhere regardless of where you look. Let's compare this to a landscape. A homogeneous and isotropic landscape would be like a vast, endless desert in which the sand is evenly distributed everywhere, and in which there are no hills, valleys, or other geographical features. No matter which direction you look or where you go, the landscape looks the same everywhere, and there are no preferred or special places. In the case of the universe, this would mean that stars, galaxies, cosmic nebulae, and other phenomena are roughly evenly distributed in space. However, recent discoveries by the James Webb Space Telescope and other astronomical observations have shown that the universe may not be as homogeneous and isotropic as previously thought. The quasars and the Great Ring prove it. It may be strange to imagine the entire universe as a landscape, but on closer inspection, this idea is not so far-fetched. Only the dimensions are somewhat larger. Here we have galaxies with millions or billions of stars. These wander around the universe along filaments and come together in groups. We know of gigantic empty spaces, the voids, black holes, and other phenomena. All these objects take part in the cosmic spectacle. Researchers have now discovered that one side of the sky has about 0.5% more quasars than the other side. Quasars are extremely bright galactic nuclei powered by supermassive black holes. This uneven distribution further suggests that the matter in the universe is not evenly distributed after all. The second discovery that speaks against the theory of a homogeneous and isotropic universe are two extremely large cosmic structures, the Big Ring and the Giant Arc, phenomena formed by galaxies and galaxy clusters. These structures are so large that they exceed the scale on which the universe is supposed to be homogeneous and isotropic. Basically, they are so large that our measurement techniques fail here. Such megastructures show that there are something like high mountains within the landscape of the universe, and nobody currently knows how they have emerged from or fit into the overall structure. But these are just the latest discoveries that are slowly but surely reinforcing the suspicion of a heterogeneous universe. Before these latest exciting discoveries, there were already indications from the different expansion rates of the universe. Here, different methods of measuring the expansion rate of the universe gave different results. We know this difference as the Hubble tension. If the universe is not the same everywhere, this would explain why it is not expanding uniformly. Somewhere between the levels of the cosmic microwave background and the local universe, the standard model of cosmology seems to be breaking down, and scientists are racing to understand what this means for our understanding of the cosmos. The James Webb Space Telescope, JWST, has indeed played a crucial role in current astronomical research, particularly in confirming discrepancies like the Hubble tension. This tension arises from measurements of the universe's expansion rate using different methods, suggesting that the universe might not be expanding uniformly. The cosmic background radiation, CMB, adds an intriguing layer to this discussion. The CMB, considered the afterglow of the Big Bang, shows a remarkably uniform distribution of matter across the universe. This uniformity was a cornerstone of the assumption that the universe is homogeneous and isotropic on large scales. However, recent discoveries and observations, including those from the JWST, challenge this notion. They reveal anomalies such as uneven distributions of quasars and the presence of extremely large cosmic structures like the Big Ring and the Giant Arc. These discoveries lead to fascinating theories. One such theory proposes that the universe may not be expanding into empty space, but encountering obstacles or other dimensions as it expands. This encounter could disrupt the assumed homogeneity of the early universe, introducing variations in matter distribution over cosmic scales. Such theories hint at a universe that is more dynamic and complex than previously imagined, possibly interacting with other universes or dimensions within a multiverse framework. Drawing an analogy to our own Earth's geological evolution, from a homogeneous early state to a heterogeneous current state, illustrates how celestial bodies can evolve over time. Similarly, the universe may have undergone or is undergoing transformations that challenge our traditional cosmological models. In summary, the JWST and other advancements in astronomy are pushing the boundaries of our understanding of the universe. They challenge established theories, suggesting that our cosmos may be more varied and intricate than we had previously theorized, prompting deeper exploration and new avenues of scientific inquiry.